Number 3. Let's get going with number 3. Let's see what's happening here. We have been asked to draw a velocity time graph. Now, this is different. In the previous questions, what we've done so far is draw a speed time graph. And what's the difference? What is the difference between speed and velocity? Think about it. You should have an answer. What is the difference between speed and velocity? Yeah, you should have said velocity has direction. And that's a game changer. That matters in terms of how you're going to approach this question and how the graph is going to look. Velocity has direction. We're interested in drawing the graph for the first 4 seconds. We know the initial speed is u. We know we have a situation where a ball is being projected vertically upwards from the ground. And that means that it's going to come back down. And they say it comes back down in 4 seconds. What goes up must come down because of our lovely friend, gravity. Now think about this. When it's going up, the ball is going, in that 4 seconds, the ball is going up. And then it's getting to come back down. So it's going up. It's going to get to, I'm starting off with a velocity u. Visualize it. Hope you can see what I'm saying here. I'm going to go up to the top. I'm going to get a velocity of 0. It's going to get to the point where it can't go anymore. Velocity has reduced that. Gravity has reduced the velocity to 0. That's the maximum height. And then it's going to come right back down to the ground. And when it comes down to the ground, in that whole journey, when it's coming down, what's happening? The speed is going from a speed of 0 right back up to u, but the velocity is different because it's going in the other direction. So I'm going from u up to 0, and then when I come back down, because I'm going in the opposite direction, although at the point it hits the ground, the speed is going to be u, but the velocity is going to be minus u. So put your graph. Your graph needs to look like this. Yeah. Hope you thought it. Did you think about that? Yeah, that's what needs to happen here. U is your starting point, but it goes down to minus u. And that's all. That's it for 4 seconds. Velocity starts at u. The ball is going up. It's decelerating. Yeah. It gets to 0. And then it's going in the other direction to minus u. Okay. Think about that. If you're not happy with it, pop me a message, or if possible, to talk to me. If you're in one of my classes, talk to me in a class, ask the questions in class, so we can deal with this. But that's what's supposed to happen because you're dealing with velocity and not speed. A good question would be, well, what would the graph look like if it was a speed time graph? You're up for it, draw it and send it to me. Okay, let's move on to part B. Part B. Before marking, sorry, I forgot about that. 1 for the shape and 1 for the correct figures. That's how it was set out here. Okay. Part B. We want the max height. Actually, we told what the max height is. My bad. And we want to find u. We're told the max height. We want to find u. They talk about in the first 4 seconds. That doesn't matter. That's a bit of a curveball there. Because we already know from drawing the graph that, well, it took 4 seconds to get back down to the ground. Which means, how long did it take to get to the max height? We know S is 19.6 m. Should have an answer. We know we want to find u. We want to know what speed we started off with. We know at the max height, that's the instant where the velocity is going to be 0. That will happen in 2 seconds. Because it's minus 9.8 is your acceleration going up, and then coming down, it's 9.8. We get some symmetry in terms of the time it takes to go up is the same time it will take to come back down. It will travel the same distance in the same time, just opposite directions, different displacement. Hope that makes sense. Think about it. Think about it. Okay, so we have those values, and we can use again our friend S is equal to half u plus v multiplied by t. We plug those numbers in. It reduces to u is equal to 19.6. That is a bit of a curveball. I mean, if you got that answer and you're smiling now, yeah, I got it right, you're probably thinking, well, damn, I didn't expect that. They gave me the max height, and the max height is actually the velocity. Whoa. Yeah, that's what happened. That's what happened here. Okay. Right. Hope that all makes sense as usual. If it doesn't, send a message. I'll explaining what your concerns are, or what be as accurate or detailed as possible, and I'll try my best to unplug your to unlock your understanding in terms of how to design this model. Okay, that's it for number 3. Sorted.